I know, but I forgot until now, so we're a little late with it. All right, so bell ringer, one, or dash 27. I'm gonna here on submit assignment, and there we go. All right, so you're gonna label each as an element, compound, homogeneous mixture, or heterogeneous mixture. Remember, if it's an element, it'll be on the periodic table. So salt water, what makes up salt water? Salt and water, so it's gonna be a mixture. So is it homogeneous or heterogeneous? If salt is fully dissolved, can you see the salt?
No.
All right, I got your message, Ariana, that's fine. So if you can't see it, then it's going to be homogeneous. Oh, I better put my mask on. Nobody told me my mask is off.
I
I
did
have a
not
mask on. Okay. All right, so it's gonna be homogeneous. Hydrogen, can I find it on the periodic table?
see. Oh, yeah.
Yes, so it's an element. Air. Now, we can't see what's in air, but remember, if the sun shines through, can we see the dust particles that are there? So there are things in the air that we just can't see. So if it's got different things in it. It's a mixture, it's gonna be hetero,
Number 3.
yeah. Just plain water. What is water made up of?
Water.
No. What is the chemical formula?
I don't know.
Hydrogen, yeah, H2O, hydrogen and oxygen. So it's got two elements in it, so it's gonna be a
Compound.
compound. And then salad dressings. We can see all the different things in it. We can see the seasoning in salad dressing, right? So it's heterogeneous. All right, so then you're gonna submit that. And every year, or every semester, excuse me, you have to, whether you ride the bus or not, you have to
What's the bus?
go through this bus safety thing. So, if everybody will click, and we're gonna do it together, click on fourth block only, bus safety. You're going to type your name here, first and last name. And we will watch the second one. I'm going to just pretty much quickly just make sure that the important thing is if there's an emergency and you're riding the bus, you have to stay as calm as you can. You need to listen to the bus driver, follow directions of the bus driver, know what to do or what emergency exits to get out of, and tell the driver immediately if you're injured. If you want to listen to this, it's me going through the PowerPoint. So I kind of just summed up that last one right there.
Do we have to really watch it?
If you're doing it with me,
Yeah.
no, the PowerPoint. But we will watch this one right here.
Yeah.
Because I don't think it's that.
It's 4 minutes.
It's 4 minutes. Oh, guess what? I don't have sound there. Do y'all mind if it's soundless?
Doesn't matter. I watched it 500 times
Yeah.
already.
So I'm gonna let that play, and you're gonna go through and check these two and submit.
Now?
Yes. We'll let that play in the background here. So check these two and submit. Andrew, you don't ride the bus, right? And Camden, you do, but you've seen it, you remember from last semester, and we're gonna be done with it.
And the years before.
Yeah, I don't wanna have to go through The only difference is how they do the road crossing now. You've got to pay attention to your driver and he'll tell you how to come across
Roger
and
never
so
does
forth.
that, so.
So Ariana, make sure you do, submit this. I don't know if you ride a bus, if you do come to school, but everybody's required to do this. So put your name. It's up to you whether you listen to those and check those and submit.
Put a
And,
check in the box.
yeah. All right, so we got that out of the way. So I'm gonna have to check that to see who else in the school has
This is a long
completed.
period.
All right,
Hopefully I'll pass it.
let's go down back to here. All right, we're going to be, talking about properties of matter. Do you guys want to type it on the computer or do you want a copy? You're gonna type it?
Yeah.
Do you want to handwrite it, Andrew, or do you want to type it in the computer as we go over it? Type it, okay. So if you're gonna do that, you can scroll on down on yours to the candy below. And then if you will pay attention to me while I'm up here, or while I go through the PowerPoint. Let me get it started and I'll be stand.
I'm not there yet.
All right, so we're gonna quickly go through properties of matter. Tomorrow, we're gonna talk about density or finish up with this, we'll revisit density with. surprises.
Yo,
All right, Jacob,
yo.
is that you or Jacob? That was Jacob, right? All right,
What's good, bud?
Jacob. Never know what. Andrew. All right,
Dang, bud, let's link up, bud.
Jacob, no, you're interrupting class. So, I'm going to.
I'm sorry, Miss Noel.
Oh, I understand.
I'm off mute. Don't say no loud.
All right, there we go. See if that lasts, if she ends up. All right, properties of matter. These are characteristics. So we have physical properties. All right, physical properties, these are things that you can observe with your five senses. It doesn't change the object. So mass, volume, shape, color, size. Luster is like shininess. Here, if we're dealing with rocks in earth science, with the rock cycle, one of the characteristics of determining what type of stone you may have is hardness. You use a scratch plate and it's whether or not it can scratch it and what type of mark it makes. So these are all physical properties, things that we can use to describe the object without changing what it is. So you'll fill in those. Good. Melting point. This is the temperature at which a solid becomes a liquid. So this is a melting point. The substance is still the same thing. So water, whether it's ice or in a gas, it is still water. It is still H2O. So melting point is a physical property. Boiling point is a physical property. So this would be, for water, it would be 100 degrees Celsius. And it is the point at which liquid, like water, would become a gas, or any liquid becomes a gas. Each liquid has its own melting and boiling point. We good?
Yeah.
All right. Okay. Viscosity. Think about honey and how slow when you try to get honey out of the jar. That is viscosity. It is sort of the resistance to flow. The higher the viscosity, the slower the liquid is going to flow. Water flows very easily, so it has a low viscosity. Honey would have a high viscosity. If you heat honey, though, it allows it to flow easy. It will change its viscosity, but it's still honey. It's not changed. So just think about how thick the liquid is when you think about viscosity. Thicker it is, the higher the viscosity. All right. Got all your points?
Yeah.
All right, solubility. Hopefully a lot of this is a review. Solubility is just how well a solute will dissolve in a liquid or in a solvent. It doesn't have to be a liquid. So a solute is what's going to be dissolved. So usually it is a solid. It can be a liquid. It is like lemonade powder if we were going to make lemonade. The solvent is what's going to do the dissolving, and most of the time it is water. And the resulting lemonade is what is the solution. And anytime you see the word solution, we're thinking homogeneous mixture.
What is being dissolved? No, because once on it, after dissolving is a blank. That's supposed to be there.
Oh, I left dissolving. I should have deleted dissolving. So leave that one. Density is another physical property. We're going to do quite a bit with density tomorrow. We may talk about it today, but we'll revisit it tomorrow. This is where we find the mass of an object and we find its volume, and we divide mass by volume. And density doesn't change. So it doesn't matter if you have a chip off of a rock or the actual rock. As long as it's made up of the same substance, its density will be the same. Look at the 2 units. Notice it's going to have 2 units, either grams per centimeters cubed or grams per milliliter. So you've got to have grams as your mass, centimeters cubed or milliliters is your volume. You have to have those 2 measures.
How you put the 3?
If you go up to the top, right here, there is a X with a little 2 at the top. Click on that. Nope, too far. Click right there. Now type your 3. Oh, whoops, get back in there. Now, click on the X. That's how you do that.
Let's see.
And if you need, I don't know if I have you type out the formula or not, but formula can be typed out. You have to type it, you can do mass slash volume.
No.
All right.
All right.
All right. So mass is always measured in grams and volume, either milliliters or centimeters cubed.
You
Huh?
skipped it. Okay. Got that mass measure.
Oh, I do, okay. Oh. Okay. Let me see. Yeah, in grams, which is G, using a scale. Volume is measured in, I left the other blank out. So I did blank or, and then no blank. So ml or cm cubed using two different methods. You can just put it all in that one blank. All right, so, got it? All right, so finding volume, if it's a solid and it has a regular shape, like a cube, rectangle, even a triangular prism, anything we have a mathematical formula for, you can find the volume mathematically. They give you two here, rectangular prism and a cylinder. So you would use the mathematical formulas, you would learn in math class to find those volumes. I don't know if you can get the pi symbol, so put 3.14 for pi when you get to that one for cylinder. There may be an equation button, but we're not gonna miss it, but you put 3.14 for pi.
That's two,
R with the 2 up in the air and then H. So length times width times height for a rectangular prism, a cylinder, like a Coke can, is 3.14 times radius squared times height.
wait. It's on the backspace.
You would measure the height and, or the units for this volume would be centimeters cubed because you would use centimeters to measure the height. All right, and then there's an example. So if you want to find the density of, just, sorry.
On mute.
You good now? No. Let me know.
There's some other right there, so we can listen. Good job for your video.
H. After, and then, one. Yours turns blue. Make it, take where it's not blue anymore. Anyway. All right, so we want to find the density of a box. We know its mass is 5 or 15 grams. And it's got its dimensions there. So the volume is going to be, we've got to find the volume first. These are two formulas. So what you would type is this next part right here, volume equals 10x 5x2. And then you can just put out to the side equals 100 cm cubed. Once you have your volume, you're going to take the mass.
So what all do we take?
You're going to type these two right here. But you, instead of the second one, you can type at the end of this just equals 100 centimeters cubed. So you would type V equals 10 times 5 times 2 equals 100 centimeters cubed. Then you're going to take, your next thing you're going to type is D equals 15G slash 100. And then we're going to get the answer.
15 grams over 100.
Yeah. And the answer is going to be 0.15 grams slash centimeters cubed. You have to have the units. So if you don't have a unit, if I were giving you a test and you were working by hand, it wasn't multiple choice, you would have to make sure you put the unit with it. We're going to work on this tomorrow, so I'm going to go through a lot of these tomorrow, and that's going to be our lesson is just solving some density problems. So this is volume dealing with a solid. So we're good.
Yeah.
If you need a liquid, it's real easy. You're going to use a graduated cylinder. Or if you've got a solid object like a marble or something like that that you can't really measure with the volume, you're going to use something called water displacement. So you're going to put enough water in the graduated cylinder to cover the object. You're going to record just the water. You're going to add the object in without splashing. You're going to get another volume because it's going to cause the water level to rise. You're going to subtract those two volumes. You're going to take this volume here with the object in it, subtract the original volume of just the water. Do that. And you're going to get the volume. So if it was just a liquid, you'd use a graduated cylinder, you would read it by the meniscus and record that, or you would do this. I didn't have any blanks there, right?
No.
All right, so example 2, if a sample of aluminum is put into 10.5 milliliters of water, the water rises to 13.5 when the aluminum is added, then what is the density if the mass is 8.1? And I'll do it on the board once I get all the typing up so you'll know what to write. So we're looking for the density, so these are the formulas we're going to use.
We just have to use.
So the first thing you're going to type is D equals 13.5 minus 10.5 equals, and that should be 3 ml, 3
So D equals.
V equals 13.5 minus 10.5 equals 3 mLs. Yeah, then you're going to do your density. So you're going to take, and we're going to write it like this on the computer. Density equals the 8.1 grams. You don't have to have grams in this first part unless you just want to. 3 milliliters equals 2.7 grams per milliliter. So we'll be doing some practice problems with this tomorrow. So if you can see what's on the board, that's what you're going to type in that part. So I can move on, but you can see it there. We're not going to do practice right now. We're doing that tomorrow. All right, chemical properties. So we're just going to keep moving. Remember, physical properties doesn't change the substance. Chemical properties will change the substance. So it is going to change the identity of it. You're going to get a new substance formed. So you're going to observe a new substance being formed. Here are some terms: toxicity, flammability, combustibility, radioactivity. Notice what they have in common at the end.
The Y.
Sort of the ITY. Generally, that is going to be a chemical
Yeah.
property, those terms. Solubility, though, is not. That is a physical property. But most of the time, if it ends like this, it will be a chemical
ITY.
property. Yeah, most of the time. All right, so
Well,
combustibility is the next little section.
then what causes rust?
So it is how easily a substance will set on fire. So, like burning charcoal, burning wood, how easily it will set on fire. Reactivity is how easily a substance reacts, usually with an acid or base. Fluorine gas is highly reactive and will spontaneously ignite a concrete block at room temperature. Oxidation is how easily a substance will react with oxygen. So iron reacts with oxygen and moisture, so it has to have some water that will create rust. So those are 3 examples there. And then the last part is changes. So properties are used to describe. Changes is the actual, what is going on, the actual change that happens. So physical it only is going to affect this physical property. So if I've measured a sheet of paper and I know it's 8.5 by 11 inches and I go and cut it in half, I've done a physical change. The property size the paper size changed. It's still paper, it's just a different size. So cutting, coloring, crushing, melting, boiling, as long as the substance is still the same thing, then, and you've modified it in some way,
Eggs.
huh?
Eggs.
Um,
The same thing.
no. Cooking is going to be, when they mean boiling here, they mean turning a liquid to a gas.
Okay.
Not in the sense of cooking something.
So what would it mean?
Huh? Boiling here for physical change is changing
No, I'm
from,
saying like it wouldn't be food. What would it
oh, just a liquid, any liquid to a gas, so water to water vapor. That's boiling. If we're talking about cooking, it's gonna involve a chemical change because what you're cooking, whatever's in there is gonna go through a chemical change.
So
How
if you
would
put
eggs
eggs, it
to
doesn't
go?
let the chemical change.
You just change.
Does it get
what look
softer?
like.
Yeah,
There's something that's going on in there.
it's soaking up the water.
That one I'd have to look up, but I know egg definitely it goes through a chemical change.
How?
Because it's
Turn it
not,
from a liquid to a solid. The inside of the egg.
yes, but boiling takes you to not a solid.
Hard egg.
It takes you to a liquid, so that's why it's a chemical change for an egg. Your egg doesn't become liquid.
Well, it's already a liquid, so it's something into
A solid
Solid.
boiling, you're cooking it, so there's something else going on there.
Okay.
So a chemical reaction is when you get a new substance is formed. So burning, rusting, decomposing, so you've got to think, do I get something new? Rust is something new.
I change the substance that affects its chemical properties, thus a
Chemical reaction.
Chemical reaction process by which.
All right, chemical reaction. This is a process by which atoms of one or more substances are rearranged to get a different substance. And we're gonna have a whole unit just dealing with chemical reactions. Basically, a chemical reaction is a chemical change.
I don't think you got it.
Is that almost?
Mhm.
Okay. Then the last little part, law of conservation of matter, and we're gonna be coming back to this a lot, in our chemistry unit. Matter is neither created nor destroyed
So
through
matter-
a chemical change.
There's matter energy.
Yes,
Can energy be
Yes.
created or destroyed?
no,
Okay, so if someone dies, then that would mean their soul or energy moves to another body, right? If it can't be created or destroyed,
well, a soul is not necessarily energy.
yeah, but your energy, you know what I'm saying though?
Well,
Like your
Your-
like the energy you give off.
your body will, that's a different energy term. Your body actually decomposes, so it turns back into, it breaks down. So mass is not lost even when a chemical reaction happens. We're gonna get really into this when we get into chemical reactions.
Yeah.
Now, the last part is the evidence of chemical change. And here are signs. Light will be released. If you're doing the chemical reaction in like a beaker or a test tube, you would feel that it either got cooler or hotter, or no change at all. An odor may be produced. Think about a decaying animal, how it smells after a while. A sudden color change, so when you mix two liquids and you get an immediate change in color. A gas given off, this is usually in the form of bubbles or like steam, is how we would know that a gas is being given off. Or when you mix two liquids together, you see a solid form, and we call that solid a precipitate. So once you get these, you can submit your notes, and we'll be done with that. So easy 20 points if you do that along with me. Then we're going to work on using this information.
Video.
Yeah, there's a video, but there's a worksheet too, so I want to talk about both of these. Is everybody through with what I have here?
No,
Okay.
almost.
All right, so if you go, oops, down here to next, or you can go back to modules, but next will work. Here's a video that you're gonna watch in just a little bit, but I want to go over the next thing first. Hopefully yours will show up, and when I'm in student mode, it doesn't like to show up right. Well, it's next.
It's metal sheet.
All right, there's this sheet right here. So the first part, all you're doing is typing a P for physical or a C for chemical. So you need to think, if this happens, will I get a new substance? If you will get a new substance, you're putting a C. If it's still the same substance, you're putting a P for physical. Part 2 is dealing with changes, so it's still P and C. You can use the same thing. Are you getting a new substance? Or are you not? Is it staying the same? So a P or C, physical stays the same, chemical, it creates something new. So just P's and C's in that first part, and if I can get it to roll without marking on it. Then down here, all right, part 3. I've got 10 things listed here. The directions say, can you recognize a chemical physical change that happened all around us? If you change the way something looks but haven't made a new substance, it's a physical change, P. If it has been changed into another substance, it's chemical change, C. So determine each of these statements if it is a physical or chemical change. Oh. And then this last part is a scenario, and you need to decide if a physical or chemical change has occurred, and then give the evidence for your decision. So what is it that happened that led you to decide it was physical or chemical? All right, so that's what this and the video is what you're doing the rest of the class. So if you have questions, you can ask, and I can help. Otherwise, you're working independently. If you don't have any questions, Ariana, you're welcome, or you're free to close out.